This is systems, matrices, and partial fractions review. Let's start with this system with three variables, with logs, some exponents, all the whole 9 yards here. First thing we want to do, I want to clean this up a little bit. I noticed that we've got log base W of all of these things, but it's 2, 8, and 4. So I'm going to rewrite those as powers of 2. We've got 12 times log base W of 2. No problem, can't really do anything with that one. We have 8 times log base W of an 8 can be written as 2 cubed. Luckily, when we have an exponent inside the logarithm, we can pull it out, say it's 3 times 8 log base W of 2. We've also got 4 log base W of 2 squared. Again, same sort of rule, multiply that by 2 on the outside so we don't have that there. Now, let's deal with those. Let's maybe swap these two so it's the y's are lined up with the y's and the z's can be lined up with the z's. And let's just copy those down. Minus 2 times 2 to the z plus 4y equals negative 22. Plus 7 times 2 to the z plus 2y equals 15. And plus 5 times 2 to the z minus 3y equals 37. Now what I want to do is I'm going to make a substitution. Let's make log base W of 2 equal to u, and let's make 2 to the z equal to v. I don't have to do anything with the y because they're already pretty nice, but now I've got these are v's, v, v, and u, u, u. With this lends itself really well to a matrix. What I can do here, I can set up my matrix. It'll be a 3 by 4. I've got the numbers 12, negative 2, 4, negative 22. That's what it equals. I've got 3 times 8 is 24, 7, 2, and 15. And I've got 2 times 4 is 8, 5, negative 3, and 37. Let's go into the matrix. You can go edit matrix A, make it a 3 by 4 matrix with the right numbers in there. Notice there's a little tiny error which will throw everything off if I do it. In fact, if I put in the reduced row echelon form for that right now, it gets really weird numbers. And the problem is, what I've done wrong is looked up, this should be positive 2, but for some reason I made it negative 2. So let's make this a 2. Again, we've got a 3 by 4 matrix with the entries all put in. We can quit out of that. We'll go into matrix. Let's do some math. And let's scroll down to take it into reduced row echelon form. Reduced row echelon form for matrix A comes out to be some nice numbers now. Much better than what it was before. So this simplifies to 0, no, 1, 0, 0, 0, 1, 0, 0, 0, 1, and the numbers in there are 1, 1, and negative 8. Or in other words, the first variable, when u is 1, or 1u, is going to be equal to 1. The second variable, the second one was the v's. V equals 1. And the final variable, y equals negative 8. Now, I'll stick with the y equaling negative 8. That's a nice one because I left y as it is. But I need to put my u's and my v's back. So for example, 2 to the z, that was equal to v, which is now 1. 2 to the z equals 1. The only thing that I can, like 2 to the only power is ever going to be 0. So z's got to be 0. 2 to the 0 equals 1. The other one, log base w of 2 equals u, which is 1. So the base is w to the first power equals 2. If w to the first power equals 2, then w must equal 2. W is 2, z is 0, y is negative 8. Let's go on to the last ones. Find the product if possible. So one way to check if it's possible to find the product is by looking at the dimensions or the order of the matrix. This matrix right here is a 3 by 1 matrix, and it's trying to be multiplied with a 2 by 3 matrix. 3 columns, or 3 rows, 1 column, times 2 rows, 3 columns. This does not work out, and you can tell because these two numbers have got to be the same. It'll sort of fuse together, and you would end up with the 3 by 3, but we can't do that in this case because it doesn't actually match up. Another way you can see this is if you line up the way that you're going to multiply. We've got the numbers 1, negative 5, and 3 with the numbers 6, 0, 5, 4, 8, and 1, negative 1. If I was to match up, you sort of work your way in to each spot. The 1 matches with the 6, but I need something right here to multiply with the 0. This one does not work out. In this second one, we've got 6, 5, 8, 0, 4, negative 1, and we're multiplying that with 1, negative 5, and 3. You can see that this one does work out because the 6 multiplies with the 1, the 5 with the negative 5, and the 8 with the 3 to get us what goes in here. Same thing with the bottom row. The 0 with the 1, the 4 with the negative 5, the negative 1 with the 3 to get us what goes in there. So let's work through these. 6 times 1 is 6. 5 times negative 5 is negative 25. 8 times 3 is 24. Adding all these up, I end up with 5. 0 times 1 is 0. 4 times negative 5 is negative 20. Negative 1 times 3 is negative 3. This comes out to be negative 23. The final matrix I get is going to be a 2 by 1 matrix with the entries of 5 and negative 23. The last one, and by the way, again, you can see that with the dimensions. This is a 2 by 3 multiplied by a 3 by 1. The 3's sort of fuse together, and you end up with that 2 by 1. Here I'm multiplying a 3 by 3 with a 3 by 3, which could be pretty annoying, but there's so many zeros here that so much of it will cancel out. I have 1, negative 4, 3, 0, 8, 0, and negative 2, negative 1, and 5. And I'm multiplying that with 3, negative 4, and 1, with the rest being zeros. So let's see. The number that goes in here, that's going to be 1 with the 3, 0 with the 4, 0 with the 3. 1 times 3 is 3, and the rest are just zeroed out. This one right here, 1 times 0, zeroed out. Negative 4 times negative 4, negative 16. And 3 times 0, 3 times 0 doesn't work, or zeroed out. In fact, every single one of these is actually just going to be a single multiplication. Down here, the entry that goes in here is just going to be 1 times 3, which is 3. because the zeros cancel out with the 1 and the negative 4. This one right here, 3 times 0, 8 times 0, 0 times 0 is 0. 0 times 0, negative 4 times 8 is negative 32. 0 times 0 is 0. Zeros, zeros, everything's zeroed out here. Negative 2 times 3, negative 6. Negative 1 times 0, 5 times 0. Negative 2 times 0, negative 1 times 4 is 4. 5 times 0, nothing. Negative 2 times 0, 1. Negative 1 times 0, and 5 times 1 is 5. This is the matrix. Now, you might notice some interesting patterns that go on here, or perhaps not. For example, this entire row just gets multiplied by 3, because that's what happens with this 3. This entire row is just multiplied by negative 4, because that's what happens with this negative 4. And this entire row is just multiplied by 1, which is what happens with the 1. That's it for this first page of review. I hope that it's useful.